Hi, it's Joshua coming to you from here in Abbotsford, British Columbia. Had to put my camera on the back of a chair there, so I'm hoping that my head's not cut off here. This past few days I've been researching thermoconductors, the Peltier effect, thermopiles and things like that. And the information that I've gone over, from what I understand, if you took a piece of wire like this, one would be copper, one would be steel. If you heated this up with a candle or a lighter or a torch, you would get roughly 0.4 millivolts. I'm not sure what the amperage would be. And I've been considering using the joepipe as a heat source, and which is par none. It's up there. It creates a lot of heat. And I'm just going to wind these together. I have 7 of these thermocouplers. Just going to wind them together. The pigtail on this is fairly small, so that tells me I could easily have maybe 2 dozen pair hooked up. It's going to actually have 24 thermoconductors or thermocouplers all connected together, and put some kind of a copper banding on it. And with the joepipe, I'd easily be able to heat that up. Heat's not going to be a problem. So, even if you had 10 pairs, each pair would produce just under a volt, maybe 0.8 milliamps. If you take 2 of these and add them together, you multiply that by 10, that'll probably give you around 6 volts, 7 volts, and whatever the amperage is. And this would be a no-brainer for the joepipe. Using the joepipe to heat this up is not a problem. You know it's going to work. Okay, and well, what I like to do, this is just a new field for me. And I was researching out this one guy yesterday where he did made a thermal magnet. He had a magnet. He routed the backside to fit in a piece of 1/4-inch square copper. He had the lead coming out, and the other lead coming out with a smaller metal piece, and with about maybe 8 or 10-inch copper extension going down. And when he heated that up with a torch, and he was saying he was able, well, you could see it, he was actually, when you heat up the copper, it causes a positive electron flow that induces induces the iron to create a magnet. And he was able to suspend about 0.7 of a kilogram of weight, and that was quite impressive. But what piqued my attention is that he was pulling about 40 amps. And when I was looking at the vid, there's no way that when he was heating up the copper that he was actually developing. Yeah, he might got a little bit of a yellow point or red point, but it wasn't all that much. But the joepipe there, pretty well melt the 1/4-inch copper. And so I was thinking, how there might be an opportunity here to increase the efficiency of thermocouplers. From 5%, maybe bump it up to 20%, 25%, and because I do have the heat source to heat the thermocouplers to where they work. So I was thinking, if you took one example would be to make a thermocoupler out of a piece of 5/8 copper. You could go, if you went about 16 inches, and you fitted that into a piece of pipe, you could have a hollow pipe that would snug right into the copper to create your junction point, like this junction point here. So if I took that and I put that into the joepipe, I'm not sure if I heated the junction with the Joe pipe to the yellow point. I'm not sure what the voltage would be. It could be upwards of 6 volts. The amperage could be, I'm not too sure about that. Maybe some of you guys out there, maybe you could, those of you that have done hands-on in this, could get back to me on that. Using a thermocoupler that has 16 inches of copper, 5/8 copper, and and 5/8 metal, and where you're heating it up with the Joe pipe, what would the amperage be? My guess would be maybe 10 amps, I don't know. But if that's possible, then if you can make a thermoconductor that you can heat up to where you're producing that kind of voltage, the next step would be to put it together into a thermopile. And using the star stove, you can actually use this edge here as a thermopile, and you can put an array around 10 thermocouplers. You could maybe encase them in fire brick or something like that to hold the heat, and to where you could actually turn the junction point. You could actually turn the metal to virtually the melting point. You may have to put pins on the metal, but if so, if you're producing 6 amps or 6 volts for each thermocoupler, if you had 10, that would be 60 volts. And then you add up your amperage, and say if you did get 10 amps off each one, that would be 10 times 60, around 50 amps. But even if you only got 20 amps, that would be sufficient. And if you got that to work on 1/6 of the star stove, that would be 8 inches across, then you could actually put 6 thermopiles together. And when you do your math and you add up all the voltage, you're going to be over 110 volts at whatever the amperage is going to be. Now you would have a system using the star stove. You turn the whole thing into a thermopile, and this would at least work for charging a battery bank. All you need is propane or water, gas, or hydrogen or whatever. And with this presentation I'm just doing this as a debut. I'm scoping the possibility of seeing if the Joe pipe can be used to create a better thermoconductor to where it can be put into a thermopile for home generation of power. And I hope I have a few minutes here left yet. And if I do get the voltage and the amperage, another possible application would be to connect them to 2 carbon rods. You insert that into a water bottle, fill it full of water, start your star stove, and now you're cranking out. You should create a little ball plasma in the water to where you can create your magnet gas. And you can have waste oil or whatever in there, it doesn't matter, it's going to break it down. Just a thought, and please get back to me on this. I'm new and sure could use your input, but I believe that I'm onto something where you can make a better, like a super thermocoupler setup. But my potential difference in my heat and cold would be around about 1,000 degrees, just to let you know, so you can use that for your calculations. This is Joshua coming to you, debuting the Joe pipe as a potential or possibility to generate DC current by creating a better thermocoupler and thermopile. I'm going to shut this off. Please get back to me.